You must have heard of a theory called quantum entanglement. But what is it really? In this video, we are going to explore this mind-boggling phenomena of the universe. Let's begin with the basics. Quantum entanglement is a phenomenon that occurs when two particles become connected in such a way that the properties of one particle are linked to the properties of the other particles, regardless of the distance between them. This means that if you measure the properties of one particle, the properties of the other particles are instantly determined, even if they are billions of light-years apart. This idea seems like something straight out of science fiction, but it's a real phenomenon. In fact, it's so real that it has been demonstrated in numerous experiments. One of the earliest experiments that demonstrated quantum entanglement is the EPR experiment, proposed by Einstein, Podolsky, and Rosen in 1935. The EPR experiment showed that two particles can be entangled in such a way that they share a property, and if you measure that property on one particle, you instantly know what the value of the same property will be for the other particle, even if they are separated by a considerable distance. Now, here's where it gets interesting. This means that entangled particles are connected in a way that goes beyond our conventional understanding of physics. When you measure the property of one particle, you aren't just learning about that one particle, you're also learning about the other particles that it is entangled with. Let me give you an example to illustrate this concept. Suppose we have two particles, A and B, that are entangled so that they share the property of spin. If you measure the spin of particle A and find that it is up, you instantly know that the spin of particle B is down, even if it's light-years away. This may sound like magic, but it's not. It's a consequence of the strange and counterintuitive rules of quantum mechanics. In fact, entanglement is so weird that Einstein famously referred to it as spooky action at a distance. So far, we've talked about how entangled particles can share a property like spin. But there's more to it than that. Entangled particles can also share other properties, like energy and momentum. This means that if you measure one property of an entangled particle, you instantly know the value of the other property as well. In recent years, researchers have discovered some amazing things about quantum entanglement. For example, in 2017, a team of physicists entangled two diamonds that were larger than a billionth of a gram each. This means that entanglement isn't just a phenomenon that occurs at the atomic or subatomic level, but it can happen at larger scales too. But why does this matter? Well, for one thing, entanglement has the potential to revolutionize computing. Because of the properties of entangled particles, they can be used to perform calculations much faster than classical computers. This means that we could potentially solve problems that are currently impossible to solve with classical computers. Another fascinating aspect of entanglement is its potential role in biology. In 2010, researchers at University College London found evidence that photosynthesis in plants is influenced by quantum entanglement. This has opened up a whole new field of research known as quantum biology, which seeks to explore the role of quantum mechanics in biological systems. But this is not all. Recent research has also suggested that quantum entanglement might play a role in the mysterious phenomenon of black holes. Black holes are the most enigmatic objects in the universe, with such strong gravitational force that nothing can escape once it crosses the event horizon. But what happens to the information of matter that gets swallowed up by the black hole? According to the theory of quantum mechanics, information cannot be lost, and this is where quantum entanglement comes in. Scientists are exploring the possibility that when matter gets sucked into a black hole, it gets entangled with the particles that make up the black hole itself. This could mean that the information about the matter is preserved in the entangled particles, and could possibly be retrieved from the black hole in some way. This is an exciting area of research, as it could potentially solve one of the biggest mysteries of the universe. Quantum entanglement is a fascinating phenomenon that has opened up new avenues of exploration in fields ranging from physics and computing to biology and even cosmology. The fact that particles can be connected in such a mysterious way, where the actions of one affect the other, no matter how far apart they are, is truly astonishing. And with ongoing research in this area, who knows what other secrets and surprises quantum entanglement has in store for us? It just goes to show that when it comes to the universe, there's always more to discover and explore.